take a look at the MIT single variable calculus, this final exam problem. This is problem number 4, and we are required to sketch the graph of this function. So let's do that. I plot an x-axis and y-axis, and let's see what's going on. When x is equal to 0, y is equal to 0 upon 0 plus 1 is 0. And then we also notice that the curve is in one way symmetrical about the y-axis. But let's say what happens when is the maxima and minima occur. So I differentiate it with respect to x. I get x square plus 1 whole square, and then this x square plus 1 multiplied by differential of x is 1 minus x into differential of this thing is 2x. So this guy becomes 1 minus x square divided by x square plus 1 whole square, and when I make it 0, this gives us two values, x is equal to plus 1 and minus 1, where the curve reaches its maxima or minima. Now when x is equal to plus 1, this whole thing has a value 1 divided by 1 plus 1 or 1 by 2. So at x is equal to 1, we have y value of 1 by 2. And when x is equal to minus 1, this whole thing is minus 1 divided by 1 plus 1 is 2. So y is equal to minus 1 by 2. And at this point, this is minus 1 by 2. And this at this point, it reaches its minima. And we know that the value of y at x is equal to 0 is 0. So the curve kind of reaches its maxima and then starts going down. And when x is infinity, so limit of when x tends to infinity, it becomes 1 upon, let's say, x plus 1 upon x. It should be 0 because this is the denominating factor. So this is kind of asymptote. And then the same way, this is going to reach its maxima here, and then it's slowly kind of going down. For example, when x is equal to 2, y is equal to 2 divided by 2 square is 4 plus 1, 5, or 0.4. At this point, this is 0.5, so this is 0.4, and it slowly keeps going down. Hope that helps. It's very close to the graph that this function should represent.